Hello everybody, welcome. This is paper 1 from May 2022 and this is time zone 1. So I think this is actually quite a challenging paper. Question 7. A model art painting is contained in a square frame. The painting has a shaded region bounded by a smooth curve and a horizontal line. Here it is. Modern art painting. When the painting is placed on a coordinate axis such that the bottom left corner of the painting has coordinate -1, 1, -1, -1, and the top right corner has the coordinates 2, 2, the curve can be modeled by y is equal to f of x, and the horizontal line can be modeled by the x-axis. Distances are measured in meters. Use the trapezoidal rule with the values given in the following table to approximate the area of the shaded region. Okay, so they don't give us the function itself, but they give us the corresponding values at different points. So they want us to use the trapezoidal rule with the values given. Okay. Alright, so trapezoid rule, remember, is a way to estimate the area under the curve. If we start at this point, -1, -1, and we go up all the way to 2, 2, then we know we've traveled a distance from -1 to 2. We've traveled a total distance of 3 in this case. From -1 all the way to +2. We've traveled a total distance of 3. And it looks like, in this case, for our trapezoids, we have a value of -1. We have a value of... Actually, let's put it on this axis right here. We have a value of 0, and we have a value a little further, so 0, 1, and 2. So if this is once again our y value, this -1, this would be the value of -1, 0 right here. And it might be helpful if you were to actually construct something like a coordinate grid for this, I think, potentially, and then stretch it across. So this is 0, 0, here, and here. So we know when x is equal to -1, we have a height of 0.6, and then when x is equal to 0, we have a height of 1.2. And when x is equal to 1, we have a height again of 1.2, and when x is equal to 2, we have a height of 0. Remember, all trapezoid rule does is it constructs a set of trapezoids here. And with only 3 trapezoids, we can almost actually just use the formula for a single trapezoid, but let's work this out and use the trapezoid rule itself. I think it should be okay. So there's a few other trapezoid rule questions already covered in some other videos. So trapezoid rule is given to you in your formula booklet. It's the area under a curve with some starting point and ending point of some function f of x, and then this x is always matched together, can be given by 1/2 h, and then we open up some brackets and we have y0 plus yn, the starting y value plus the final y value, plus 2 times, and then we have y1 plus y2 plus all the way up to yn minus 1. And what that means is it's everything up to the second last one. Remember, this is the last one right here. So let's go ahead and write those values in. H in this case is one that we'll need to solve for, and h, remember, corresponds to the size of the intervals. Usually they'll tell us the range, that is to say the total value from beginning to end point that we want to sweep through, and they'll tell us the number of intervals. In this case, they just give us a set of values, and in some sense they ask us to infer it. So h is the size of the intervals. And so what is it? If we're going from -1 all the way to +2, and we do it in this case 3 steps, we have 1, 2, 3 equal intervals, and we know we travel a distance of 3. In this case, the size of the intervals are just going to be 1. So we know that h in this case is equal to 1. The height at the very beginning is equal to 0.6. The height at the end, right here, is equal to 0. Plus 2. And then these points, remember, are shared by two different trapezoids. It's shared by this trapezoid right here. And it's also shared by this one right here to the right. So that's why we multiply the inner values by 2. 2 times, and then this inner value of 1.2, which is right here as well, plus this other inner value of 1.2. And then we can close our brackets. Remember, when you're working through this, we're multiplying this whole thing right here by this value out in front. So be mindful of your brackets as you work this out. Okay, let's go to the calculator and find the value. Get a new screen. And so we have 1/2. Yeah, let's get a fraction, I suppose. 1/2 times 1. We don't really need to put that 1 there, so I'm going to skip it. And let's get double brackets. So we have 0.6 plus 0. Again, not entirely necessary. Plus 2 times 1.2 plus 1.2. Okay, so we want 1/2 to multiply all of this. I think, again, it's a good strategy to find out the value of what's on the inside on your calculator and then multiply 1/2. If you set it out like this, just make sure you have the double brackets. All right, and then we have the area of this section is equal to 2.7. Okay, so let's go back to the document and write this out. 2.7. Okay. Approximate the area of the shaded region. Okay, good. The artist used the equation y is equal to negative x cubed minus 3x squared plus 4x plus 12 all over 10 to draw the curve. Find the exact area of the shaded region in the painting. Okay, so the exact area of the shaded region in the painting. So remember, for the shaded region under a curve, we can use our integral. So this trapezoid rule right here gave us an estimate for the area under the curve. And that's why, actually I should probably write this out actually right here. This is an approximation. So the trapezoid rule gave us an estimate for the area under the curve, but the true area under the curve is given by this integral, given by this right here. So the sum of the values, or the area under the curve, with some starting point and ending point of some function f of x. And then we want to keep these x's, or the variables, always the same. And for AISL, it's always x. Alright, so this is our function right here. This is our f of x. In this case, we should be able to just plug this in, and if we know our starting point and our ending point, we should be able to find the exact area of the shaded region. So let's go ahead and work that out. So our starting point is -1, that's our lower bound, and we're going to go all the way up to 2, that's going to be our upper bound. Our function itself is negative x cubed minus 3x squared plus 4x plus 12, and this is all over 10. And then we want to integrate this. Essentially what we're doing, we're taking the integral. We want to integrate this with respect to dx. And of course this should just match the variable that you have as the input. Okay, so that's it. Let's go to the calculator and work that out. Menu, calculus, we want to find the numerical integral. Our lower bound was -1, and our our upper bound was 2. Our function, actually let's get a fraction to write this out, and we have negative x cubed minus 3x squared plus 4x plus 12, and this is all over 10. Our variable is x, so let's write an x right in here. And there it is, 2.925. So let's go back to the document and write this out. 2.925. Find the exact area of the shaded region. Okay. Find the area of the unshaded region in the painting. Kind of an interesting question. I'm going to actually erase a lot of this here. Pretty much everything actually. And I think I'll leave some of this trapezoid rule just because it can stay, I suppose. Alright, so we know that the area of this shaded region, we just found it out, and the area of this shaded region was 2.95. So this is, let's call it A1, and it equals 2.95. And we want to find the area of the unshaded region, so everything that is, well, not within the shaded region, essentially. And so what is the area of this shaded region? Or sorry, the area of this total thing? What do we have? We know that it's a square frame, and we know the dimensions of the frame. We found that at the very beginning. If our x value starts at -1 and goes up to 2, we travel a distance of 3. Similarly, if we start at a y value of -1 and go up to 2, or just knowing that it's a square frame, we have again a value of 3. So the area of the frame itself, we can write it as area of the frame minus area, let's change this to S of shaded, minus AS should give us the area of the unshaded, we can say. So the area of the frame is 3 by 3. The area shaded is 2.95. And then by definition, what is not shaded is unshaded. And so let's have 3 by 3, 9 minus 2.95. This gives us an area unshaded. And area unshaded is equal to 6.05. You could just write 6.05 here and that would be fine as well. Okay, not too bad. Alright everybody, I hope that was helpful, and as always, best of luck. Take care.